Hi, and welcome to this bonus lecture in our drip irrigation course. And it was brought to our attention by one of the students that we hadn't really addressed how long a run you can do with drip tubing when you're designing or installing it in the ground. And typically we're using 1/2 inch drip tubing, but there are occasions where 3/4 inch drip tubing is going to be necessitated. It's going to be required. And so what I want to do is explain how you can calculate the longest run that you can do depending on the pipe size that you're working with. Now there's two criteria that we're going to work with. One, we never want to exceed 5 feet per second. We don't want the water in our piping to go faster than 5 feet per second because it can damage the system. Water hammer can become a factor, and drip irrigation is just put together with compression. If you get too much pressure, it's going to blow it apart. The second criteria is we want to have a maximum of 10 psi loss in the system. So if I've got my system set up with a 1-inch valve, my drip regulator and filter manifold, and I've got 40 psi as it exits into the drip line, then by the time I get to the end of that drip line, however long it may be, I don't want it to be below 30 psi. That would be my 10 psi loss maximum. So let's take a look at a friction loss chart, and that's going to help to explain this to a much better degree. And I'll have the friction loss chart and an irrigation design, point source drip irrigation design that I've completed available for you in resources for you to refer to. Okay, let's look at these charts. So here we have a friction loss chart, and this is for polyethylene plastic pipe or just drip tubing. And what this is telling me is what I can do as far as velocities. I don't want to exceed 5 feet per second, and what my PSI losses are. So with 1/2 inch tubing, here on the left-hand side, I've got a flow in a gallon per minute chart. So 1 gallon per minute all the way down the line. I also have a stair-stepped area of shaded portions of this chart, and that shaded area represents areas where we are exceeding 5 feet per second velocity. So with a 1/2 inch pipe, I've got a velocity in feet per second, and I've got a PSI loss column as well. If I'm running 4 gallons per minute, which is 240 gallons per hour, I'm going to have a velocity of 4.22 feet per second and a PSI loss of 6.35, and that loss is per 100 feet of pipe. If I go to 5 gallons per minute, I'm exceeding my velocity, so I can't go there. If I want to have more than 5 gallons a minute, then I'm going to have to jump to a 3/4 inch drip tubing in order to accommodate that and stay within our design criteria. So if I'm pushing 4 gallons per minute or 240 gallons per hour, how long of a run can I do and not exceed or max out my 10 psi loss? Well, I'm going to take my calculator. 10 psi is my maximum, and I'm going to divide that by, at 4 gallons per minute, I'm going to divide that by a psi loss of 6.35. It gives me a value of 1.57, but remember, this is per 100 feet. I multiply that. I can run 157 feet at 4 gallons per minute and not exceed my loss. So that would be the maximum I could do at 4 gallons a minute with 1/2 inch piping. So if I want to do a longer run, I'm going to have to go up to a 3/4 inch pipe. So let's say I'm pushing 4 gallons a minute, but my whole run is much longer than 157 feet. Well, at 4 gallons a minute on 3/4 inch line, my velocity is 2.4, but my PSI loss is only 1.62. If I do the math again, 10 divided 1.62 times 100, I can run at 4 gallons a minute, I can run a 3/4 inch line 600 feet, almost 620 feet, and I'm going to be fine as far as my friction loss is concerned and putting my system together. So here is an irrigation plan that I did. And again, this is available to you in resources. It'll be a 24 by 36 inch document, and you can have that printed out and have it scaled to fit your size paper if you're in metric or you just want to do it on your home printer. But I've got a 1-inch Schedule 40 main line shown coming out. I've got 5 valves depicted by these little semaphores, and my maximum gallon per minute flow rate is 4.37 gallons per minute. So near each of the valves, I've got some descriptive text that says the valve number, the valve size, and what the gallon per minute flow rate is. So if I need to size this, now this little lines coming out represents my drip tubing. And this drip tubing comes all the way around, all the way down, and down to the end here. That measures 331 feet. So I've got 331 feet and 4.37 gallons per minute. So I need to be able to determine what size tubing I can run. Well, I'm over 4 gallons a minute. I'm at 4.37, almost 5. So for this example, I'm just going to say 5 gallons a minute. If I'm running 5 gallons a minute, then I'm going to have to go to 3/4 inch piping. I've got a velocity of 3 feet per second. My PSI loss is only 2.44. So again, I'm going to go 10 divided by 2.44 equals 409 times 100. I can run my 3/4 inch line almost 410 feet from valve all the way to the end, and I'm not going to exceed my PSI loss. My velocity is going to be fine, and technically, as this line is going out into the landscape, every time I put drip emitters at plants, then I'm using up some of that 4.37 gallons per minute. So it's dropping. So as I go out, at some point, if I really wanted to, I could just shift this over to 1/2 inch line because I wouldn't be pushing that much more water. From a practical standpoint, if you got 3/4 inch piping, run it out there, take your 1/4 inch tubing off of that, do your drip emitters per the schedule, and you're going to be fine. But this is how you can determine how long of a run you can do based on what your flow rate is. So you're going to have to add up what your flow rates are, figure out your gallon per hour, but then do the math, divide that out so you know how many gallons per minute you're pushing into the landscape. Then go to this friction loss chart, and you should be able to go ahead and say, I've got this many gallons per minute, and if I don't want to exceed 5 feet per second, or I don't want to be marginalizing this, I'm going to kick it up to the next larger size. And there is 1 inch drip tubing available as well. Typically, 1/2 inch and 3/4 inch is going to be more than adequate for anything that you need to do. So hopefully that's going to help clarify this to a little bit. And again, both of these sheets, the friction loss and the irrigation design, are available for you in the resources for this bonus lecture. Okay, that's it. Any questions, be in touch, and I will see you on down the line.